Hello and welcome to another sort of lab and the guided course to Make Magazine's electronics course. I'm going to be talking about something we didn't talk about. Should be talked about, in my opinion, should be covered. The diode. Very, very, very simple semiconductor. It's like half a transistor, you could kind of say, but not quite. It has a positive semiconductor and a negative doped semiconductor. You may wonder what's the importance of this. Well, diodes are pretty cool because they only let current go one way. Current can go through. Sure, current can go through the left pin from where we're looking at it. The current can go through here, yeah. Let me straighten the diode out, actually. Current can go through here. It can pass through with only a little bit of impedance, just minimal, very minimal and ignorable impedance going through here. It can continue on. However, current tries to go this way. It's not going to be blocked until it either blows the diode of exceeding it, or if the diode's faulty. It can only get past here if it exceeds the diode's rating, and if it does, the diode is broken. This is a rectifier diode, so it's big. You can't see inside of it. It's relatively big, not big at all. Let me get another kind of diode. Excuse me for a moment. Oh wait, here's a larger rectifier diode. It's got a much larger voltage rating, so it can take much more going through here before it bursts. This is for kind of heavy-duty use. I'll get to that in the future, in the next lab, actually. And here we have a regular diode, or signal diode. I don't know if we'll be able to see in there. Trying to keep it in focus. You can kind of see in there. You can kind of see a crystal. That's the semiconductor. It's kind of a semiconductor. I don't know the details of it, but the important part to know about it is, on a diode, there will be markings. And just trying to get them in both in the same view. The little line, in this case the black line, and on that one the white line, shows where current can't. That's the side where current can't go through. Current goes through here, and it goes from here through here, there. Does not go here. Does not go this way. Can't pass that way. That's what the marking means. So whatever side the line's on, depending on it might be a different color, but it'll mean the same thing. It means that current can't go through there. Now, I'm not just going to talk about that. I'm going to demonstrate it with a lab. Here, I have a jumbo LED, because I felt like using a jumbo one. This makes no difference whatsoever, I just felt like using it. We've got a 1 kilo ohm resistor, piece of hookup wire, going to the negative. Positive to negative, that's the resistor's there so we don't blow the LED with this 9-volt battery, which has some pretty sorry looking leads. I'm just going to leave the negative in. Sorry, just a moment. Right out loud. Just a moment, excuse me. You can watch me struggle. It's a mini lab here. How to straighten your wire leads. These wire leads are way too long because I accidentally stripped the cable during a scout. Oh. There we go. Okay. Negative is in. It took way too much effort. Sometimes that happens. You just kind of have to deal with it sometimes. So we're just going to demonstrate the fact that the circuit works first. No diodes in here yet. And yeah, sure enough, the LED lights up. when I apply voltage. Oh, that was bad. Apply voltage to the positive. And yeah. Okay, so now we're going to do something to the circuit to demonstrate the diode. I am going to zoom out and try to get a good angle on this. I apologize if it's not a good angle. The best I can do right now. I'm going to insert a diode. So what I'm going to do is I'm simply going to just going to move this LED over to here. Grab my hookup wire and put it on the cathode. Then I'm going to use the rectifier diode just to be safe here. And I'm going to insert it the way it's supposed to work, so current goes through. It's supposed to, so I'm going to let the positive be over here, while the end of the resistor being over here. This end is going to the LED. So just bend it a bit. There's no polarity. Well, there is polarity on diodes, but it's not signified by a larger or shorter lead. It's just signaled by the line. So the polarity is which way it can go through and can't, which makes sense, really. Short little insert here. An LED is also a diode. It's a light emitting diode. It's a diode that uses some of the energy to produce light, because that's why it has an anode and cathode. You can only go one way through the LED. If you try hooking up an LED backwards, it doesn't work. Okay, so now, oh dang it, I gotta plug the negative back in. It's in. Okay. I'm gonna apply voltage to positive. Look at that, we got some light. I expect that should happen. Now I'm gonna reverse the diode. You would never do this in an actual circuit, but it's just for demonstration's sake. I'm gonna reverse the diode. We're gonna see what happens. Okay, I've reversed the diode. So I'm gonna plug the positive in. Plug the negative in. Plug the positive in. And we've got nothing going on. That's the point of this slab. The point is to understand that a diode does not let the current go through. And if I feel it, it's going to feel slightly warmish. Not nearly as warm as I had, you know, like 20 volts going through here. I don't know what this diode's rated at. It's decently high. But that's diodes. I'm going to demonstrate what you can do with them. A very, very useful concept with them in the next slab. Thanks for watching. See you then.